In this video, we're going to go over an introduction to the Arduino single board computer. So an Arduino, you've probably heard of this, it's a very popular system right now. It's a single board computer system, and what that means is that on a little board the size of smaller than a credit card, you have everything you need for a computer: memory, storage for your program, storage for your variables, a microprocessor, in addition to inputs and outputs. The technical details of it are it's based upon an Atmel RISC-based microcontroller, and it's got everything integrated inside of a single chip. In this video, we're going to be using the Arduino Uno board, and if you look at the picture of the Uno, you'll see U-N-O right there, and that signifies that it's the Uno. There's a whole bunch of different Arduinos out there, Arduino Mega, etc., etc. But anyway, we're going to be using the Uno, and the board itself actually has the Atmel processor on it, and then it has some other peripherals. It's got the crystal oscillator to drive the clock, and it also has these pin headers, which are very important because these are pins for how you interface the Arduino processor to the outside world. Okay, what makes an Arduino different from a regular computer is that it is intended for different applications where it is to be embedded. So for example, if you think about what a regular computer is, you're probably watching this on our computer right now. A regular computer is very general purpose. It's designed to run applications, software, office programs, spreadsheets, etc., etc. It almost always has a keyboard, a mouse, and a monitor as its primary input-output devices, and then it almost always has some sort of internet connection or Wi-Fi, which it uses to transmit data. But if you think about it, it shows up and it's got an operating system, Windows or Linux, and you install software on it, you install Office, and you're able to run it. But it's designed to basically run any type of software that is written for that particular operating system. So it's very general purpose. An Arduino is not that. An Arduino does not have a keyboard, it doesn't have a mouse, it only has input-output pins. And what it's intended for is it's designed to do a very specific task, and it's designed to be what we call embedded inside of the system that it is controlling. So that's the technical definition of an embedded system. So if you think about, like a game controller, there's a micro computer inside of a game controller, there's a computer inside of your camera, there's a computer inside of everything in your car, in appliances, and those are real computers. It's just that they don't have a keyboard and a mouse and a monitor because they don't need it. They have software on them that does something very specific for that task, and that is what the Arduino is made for. As such, it can be used in a lot of different applications, not necessarily for running a keyboard and a mouse and running an operating system. It's really intended to be embedded in something else. Now, if you've heard of Arduinos are extremely popular right now, and one of the questions is why. I mean, single board computers have been around for a long time. There's a couple reasons. The people that made Arduinos spent a lot of time creating a development environment that is very, very simple. So it's a pretty lightweight piece of software. You write your code in it. It can be installed on Windows, Mac, Linux, etc. So it's very broadly deployable. So that's one of the big things, is that the development environment is extremely easy. The other thing is that people kind of caught on that this had a really easy to use development environment. So what they did is they started making these things called shields. And a shield is another board that you plug onto the Arduino board, and it plugs into the same connector heads. And what it does is it expands the capability. So you can, here's an example of an LCD shield. So this thing has an LCD on it, and you notice it's got these pins right here. You just plug it on top of the Arduino, and you write your code to drive the LCD. This is a robot shield. This has the capability to plug onto an Arduino and basically drive servo motors, and has a little breadboard. And there's just all sorts of these shields out there. So anything you can think of, it's got an Ethernet shield, it's got Wi-Fi shields, anything that you can imagine, there's these shields out there. So it started really taking off. And then along with that, there's a lot of open source libraries that have been created for Arduino. So if you go to hook up to, let's say, a servo motor, and you want to spin it, you don't have to write that code from scratch. There's libraries out there there that you can grab that are open source, and you can include them in your program, and then you just call them, and then you can pass simple parameters into that function and make the motor spin. So that's why they're so popular right now. So how do you program an Arduino? Well, you install their software, and that's what we're going to do here in a second. But when you do that, one of the most important concepts of this is that the software is called a cross-compiler. And what that means is, let's think about the typical way that you learn to program. Typically, you sit down at a computer with a keyboard and a monitor, and you launch some sort of development environment. Let's say Microsoft Visual Studio, for example. You write a program, hello world, and you run the program, and it typically runs on the machine, and you use the console or the command prompt to actually get information into and out of your simple program. Now, the input and the output are the inputs and outputs used by the computer. So you can type on a keyboard and it'll go into your program as standard input. It will provide information back to you by spitting stuff into the console screen as standard output. So it uses the same input output of the computer that you're developing on. And that makes sense because you're writing the program for the computer you're on. You're creating the executable that will be run on that same computer. That is not what is going on when you do an Arduino. What you do with an Arduino is you will actually have software on your computer, and you will write the program for the Arduino, but then you have to run it on the Arduino. The Arduino computer is actually down here on this chip. So what you do is you compile it on your PC or Mac, and then you download it and run it over here. That's called a cross compiler because you're actually compiling code on one computer to be executed on another one. I bring that up because you really got to keep that in your mind as a conceptual model for what's going on, because when you're running this program, you're used to running a program where you're doing standard input output, where you're typing on a keyboard and looking at stuff come back on the command console, except that the Arduino is running a program and it doesn't have a keyboard or a mouse. So the input and the output to this are pins and buttons and stuff like that. So you go, well, how do you interface with this? Well, there's a way that they have provided to interface with this so you can kind of debug your programs before you detach it and embed it, and it's through this cable. So this is going to be a standard USB cable that plugs into this jack right here, and when your program's running, you can open up what you call a serial monitor, and it looks just like a console, and basically you can type in characters and pass ASCII characters down to the Arduino, and then the Arduino can spit those characters back. But you'll see that when you try to go do just basic, input output stuff, it works a little bit different as if you're using Microsoft Visual Studio. And so you just got to keep in mind what's actually going on. What's really going on is that the computer program is being executed down here, and there is no I/O. You're going to have to use this serial communication line to actually see I/O. And it's programmed with C++, but it also supports a lot of the constructs in C. Okay, so let's do our first activity. What we're going to do is download and install the Arduino software, and we're going to also look at some of a tutorial that's really handy, and before we move on to actually turning it on. So the place that you get the Arduino software is at this arduino.cc. So if you go out to that website, what you'll see is all of this information about Arduinos. What is Arduino? You can get support for Arduino. You can buy an Arduino, but you can buy them anywhere. What you're interested in is coming up to download, and it's going to say you want to download this software. Okay, so it's really the main thing that you download. But look at this. It's supported on Mac, Linux, 32-bit, 64-bit, ARM. This is great about Arduinos. It's supported on all this stuff. So you go ahead in here and you go ahead and download this thing and contribute. You can donate. This is all open source, so I'm not going to donate anything. I'm just going to download. So I get this file. It's about 150 megabytes, and then you unzip it and you run the executable to install it, and off you go. Okay, so I'll cancel that since I did it before this video, and you're up and running. Okay, so now you're going to launch this Arduino software. So you go ahead and click on the little shortcut that it created, and what you'll see is that, let me launch mine here. What you're going to see is a little program that comes up. Okay, so you got this little program, and you can expand it a little bit, and this is the Arduino software. And notice it's really lightweight. It's just a single application. Let me put this back here so you can see it a little bit better. It's really lightweight, really easy, and it always comes up like this. What you're going to notice in here is that it defaults by having something called a sketch, and it's got this thing called sketch and tools and all that sort of stuff. Basically, their project, instead of calling it a project, it's called a sketch, and your program is one file. So it's a .ino file, and you're going to type this out, and you can save your sketch, and it's just a single file that's really easy. You can double click on it and it'll pop up, and you can have multiple windows running at one time, so I can have multiple sketches open. So that's the software right there. One other thing for this activity that I'd like you to do is go ahead. There's just tremendous amount of support for Arduino. So you can go out on the support here. You can search for stuff in the actual software itself. You can go in here and go to or help reference, and it'll bring you to the Arduino reference, and you can look at all of the different functions that are in it and how to use them. And if you want to know about data types, you just click on here. The support for this is phenomenal, really easy to find. So that's one of the really helpful things about Arduino. So you'll be using that a lot. Okay. However, what I'd like you to do is go out to this company called Parallax. They have created a really great tutorial that walks you through starting up an Arduino and just getting it up and running, and it mirrors what I'm mirroring what they're doing, because they did such a good job of it. But if you wanted a tutorial that was a PDF that you could read and stuff like that, go ahead and go out to parallax.com, and all you got to do is type in Arduino, and they have these products for it, and they actually have some robotics kits that are built on it. So if you scroll down and go robotics shield with Arduino, this is the shield that they have. But what's interesting is that they have this thing called ShieldBot Web Tutorial, and you can download this tutorial, which is it's large. It's got like 17 it's 17 megs and everything. It comes in a zip, and if you look at this tutorial, let me bring it up. It's 206 pages, and it's designed to walk you through getting to the point where you actually build up a robot and learn how to use the servo library and call functions to turn the motors. But if you look at this thing, it's really cool because it has this getting started with Arduino. Okay, so it's got everything that you need of hooking it up for the first time, and it walks you through what's going on in the development environment. Let's see here. It tells you about why Arduino exists and all that sort of stuff. Download and install the software. Write a simple hello sketch. And so this is something that I've found is very handy to have something that you can reference back to. It also has a series of examples that you can do, and it provides the code for them. So it'll have you say, okay, go ahead and write a simple hello program and execute it, but then it gives you the code so that if you are struggling, you can look at the solution and figure out where you're going wrong. Okay, so at this point, what I'd like you to do is go ahead and pause the video and then install the software and get it to the point where you can actually launch it on your machine. So when you unpause this video, what I would like you to do is have that software up and running, and then we'll move on to the next part, which is actually running a program. Okay, so at this point you have your software installed. Let's go ahead and do our next little module here, which is writing our first program. So the first thing that we want to do is go ahead and let's get organized so that you can see how sketches work and where they go. So go ahead and create a folder somewhere. You can call it whatever you want, Arduino code, Arduino tutorial, etc. But within this one folder, you're going to put all of your sketches. And I created a folder which is called, just straight up, I'd created it on my desktop, and it's going to be called Arduino. Okay, so I have this program right here. I have this this folder, and what I'm going to do is I want to create my first sketch. Okay, so I'm going to launch the Arduino software, and here comes my Arduino software right here, and it always comes up with this void setup, void loop in there, and we'll talk about that in the next activity. But at this point, you can type in here whatever. But what you want to do first is save this thing. And what I'm going to do is I'm going to go ahead and go File, and I'm going to go Save As. And it's going to say, where do you want to put this? So what I want to do is I want to go to my desktop. And staying organized with this is key because it'll save you down the road. So I'm going to go into my Arduino, and at this point I'm in the right folder. What I want to do is I want to name this sketch something, descriptive, but what it's going to do is it's going to create a folder, and then inside of that folder it's going to create the sketch itself. So I'm going to go ahead and I'll call this activity 2, and it'll be hello world. And I'm going to go ahead and say save. If you notice, then what happened is that over here in Windows Explorer, I have now created for me this activity 2 hello world folder. Underneath it, it's got this activity 2 hello world.ini. This is the actual sketch, and it's a single file. You just double click on this and it'll bring up the development environment. So it's super simple. So the way that you organize your projects is every time you want to do a new sketch, create a new sketch, save it, and then put it into this folder, and it'll create a full subfolder for you. So you're going to have just tons and tons of these folders as you walk through the tutorial. Okay. All right. So now at this point, what we want to do is you've launched your Arduino software. You have entered some code and saved. We haven't really entered any code yet. But now what we're going to do is let's enter some code, and then we will connect it and run it. Okay, so the first thing that I want to do is I want to enter something simple. In this activity, you don't need to understand anything that's going on with the syntax. We'll start talking about the syntax in just a second. But what we want to do is I would just want you to type the following code right here. So go ahead and type serial with a capital S, and then go begin, and then type 9600, and then semicolon. And what that's doing is it's setting up the serial communication that down the cable to the Arduino, and then go ahead and go serial.print, and then type open parentheses and then quotes and say hello world, and then give it /n as a line return, and then go ahead and do this. And now you're ready to see what's going on. Okay, so I'm going to go ahead and file, save that, and I'm going to verify this right now. So I'm going to go ahead, up here you're going to see a verify button, which is a check and an upload. I'm going to verify it, and what that's going to do is it's going to compile it. So it's coming down here. You're compiling this thing, and once it's done, it'll tell you some information, and it'll also tell you if you have any errors in there. Okay, so you can see it's kind of cranking along. The first time it goes, it's a little slower than the second time. So I went ahead and did that. Now at this point, what I want to do is I would like to connect my Arduino. So if you look at the Arduino, so here's my Arduino, and what I'm going to do is I'm going to go ahead and connect the USB cable to it, and your computer will recognize that it's connected now. And lights will come on. There's a power light, and when you download, some lights will blink. But it's now connected. And what you want to do is, once you get this set up, you'll never have to set it up again on your machine. But go ahead and go to Tools and go under Board, and it should have automatically jumped to Arduino Genuino Uno. But if it didn't, go ahead and select that. And then go to port. This is the most common problem, is that when you first install the software, it doesn't default to the COM3 Arduino Genuino Uno port. So go ahead and check that COM3, and now you should be up and running. So what's going to happen here is I can go ahead and let this thing run. Okay, so I'm going to go ahead and upload it. So I'm going to hit upload again, and it's whenever you upload it actually compiles it. So it comes along and it compiled it, and it's going to download it to the Arduino. So it said, okay, download it. Now it's running, but it's what we did here is we're trying to print something to the console. In order to see the console, okay, what you have to do is you have to come up here and you have to start the serial monitor. So the serial monitor is going to start, and I'll put it over here for you. And I'm going to say, okay, here's the serial monitor, and it printed hello world. It's like, okay, that's great. Well, the way that this program happens to run is it does it one time. So if I want to run it again, what I can do is I can actually go out here to the Arduino, and I can hit the reset button. So the program is in non-volatile memory. It's in EEPROM right here on the Atmel processor. And if I go ahead and hit this button right here, it'll reset it, and it'll run the program again. And notice how it came out and said hello world. So every time I hit that, it runs the program and it types hello world one time. Okay. With the console up, if I went ahead and verified it and uploaded it again, So I click verify there, and now I'll go upload. You get in the habit of always clicking upload. So I go ahead and do it. Notice it clears out the console or the serial monitor, and now it's going to upload it, and there it goes. So it just ran. Okay. So at this point, you are live. You have installed the software, you've written your first Hello World program, and you have connected it, and everything's good. Okay. So at this point, what we want to do is go ahead and get this running, okay? But I want to start doing some basic stuff here, talking about a little bit of the little bit of what's happening here. So at this point, you going forward, there's some prerequisite knowledge that you have to have, because we're going to start programming and start explaining the Arduino and how it's different from a traditional C program. So you should have a basic understanding of standard I/O in a computer program, data types, math operations, and decisions and loops. So if-thens, while loops, and if or for loops. Okay, so you should have that. So let's go ahead and let's bring up our sketch, and I want to show you three statements, and then I also want to talk about the Arduino in general, okay, the structure of this. So here's what's going on. This is our program that I just wrote. What you'll notice immediately is that you have void setup, and then you have void loop. They have written this development environment to abstract really what's going on the microprocessor, and it's really neat from a programming standpoint, because this void setup is going to run one time. So notice that it's a function. Void means it's not going to return anything, and then whatever's in between these curly brackets is going to be what's executed. But it will only run one time. So it's architected so that if you just have something that you want to do once, it'll just put it right here and then go. This down here, this void loop, is a function where it is going to sit there and loop forever. So you don't have to create your own loop. This will be where you're actually going to do looping things. Okay, so that's something to keep in mind, you can play with. Okay, the first thing that you're going to do is you always put this serial.begin 9600. Serial is going to be, you can kind of think of it as it's a class, but you can think of it as like a built-in library. So the serial has all these functions within it, and the functions, you call them in this Arduino programming, the C++ environment, by basically going within serial, put a dot, and then run the function begin, and then you give it the arguments. So this is as opposed to like in a program where you would include serial as a library somewhere else, and then you would just call begin. So the way that they do it in C++ is you have this thing over here, then a dot, you have your library, your class, and then over here you have your function, or also called a method. So in this situation, what this does is it sets up the baud rate. It sets up the UART communication down the USB to the Arduino, and the 9600 is the baud rate, which is the speed at which the serial bit stream is sent. When you do that, the serial monitor works. It's just, that's all you have to do to get a serial connection to talk to the Arduino using the USB cable, and it will communicate back and forth. And so you can see how easily how easy it is to program, because it's abstracted all the stuff that it just did for you. So you just put that in there and bam, it works. The next one that you're going to use a lot is going to be a print function in the serial class, or the serial library, that's just called .print. So you're going to put print. And the way this works is, it's really powerful, because if you put print, it's inside the parentheses. If you put double quotes, you're going to put text. Okay, so if I type hello world, it'll type hello world over here on the console. And when you do serial, what it means is that it's going to type that as ASCII characters that are sent back up the cable and are put in the serial monitor. Now it supports a few different ways of doing things. You can have this /n as a new line, and you can have multiple new lines if you want. Or they also give you serial.print line. Okay, so if you want it to automatically have a carriage return at the end, you could type this one. This has a line, or excuse me, this has a return. Okay, so let's look at the difference here. So I'm going to have print hello world with 2 carriage returns. If I have print line, then it's going to have a carriage return automatically. Notice that these are both in the setup function, so that means they're only going to execute once. So if I go ahead and say, let's run this thing and see what happens. So what I should see is hello world will will be printed with 2 returns, 1, 2, and then this has a return. That didn't really help us because we couldn't see the return. So let's put serial.print again and say I am here. Okay. Let's do it like this. After hello world, I want to see I am here. And let's put it like this just so we can see if there's a difference. And so let's go ahead and run this. So I want to verify it. Save and verify. And it goes ahead and cranks, downloads it to the Arduino, and the Arduino uploads it back to here. Hello world. Then notice that there was 2 returns in it. It says I am here. Notice that since I used just .print, it didn't have, I didn't put the new line in there, the carriage return, and so when it went down to print, this has a return. Notice how it's butted up right against it, so I didn't have that return there. Notice, however, that when I did print ln or print line, I didn't have to put that carriage return, the /n, and it automatically put it there. So that's the big difference with print ln and print, is that it just puts a return at the end, and then you have I am here. Okay, so we've got our first 3 functions. The next thing that I want to do is let's take a look at what would happen if I put this in the loop. Okay, so now this is going to sit, it's going to execute, it's going to go through the setup function once, then it's going to get in the loop function, and it will sit here forever. So I'm going to do it like this. I'm going to say I am looping, and I'm not going to put a carriage return on it, and let's just see what happens. So Control S is save, so I do a Control S, and I'm going to see how this works. So it should come through here. It'll say I am here, no carriage return, and then it'll start. It's writing like crazy. Okay, so it's going nuts. And the only way to stop this is basically turn off the Arduino. It's running and it's not going to stop. So now this is not the greatest thing ever. One, it's not doing carriage returns, so let's go ahead and put a carriage return on there, and let's go ahead and see what that'll do. So I go ahead and start doing that. And now it's really gone. So I got a carriage return there. Well, this is not the greatest thing ever to just have it write as fast as it can. So there is yet another built-in handy library or class within the Arduino system, which is just simply provides a function called delay. Okay, and all I do is I type delay, lowercase, it's case sensitive, and I just put the number of milliseconds that I want in there. So I'm going to put 100 milliseconds. What this means is that it'll type this and it'll wait for 1/10 of a second. Let's actually make it like 250, so a 1/4 of a second, so you can see that it's slower. And then it'll wait a little bit, and then it'll loop. So let's see how different this is. So let's go ahead and verify that. And we're compiling, no errors. And now it is off. I am looping. Notice that it's way, way slower. And it's because it's only writing every 250 milliseconds. If I wanted to do it every second, I could absolutely do it every second, and I would just do this. Okay, so it's going to compile, it's going to download it, and here it goes, 1001, 1002, 1003. So it's up and running. Okay, so at this point you have the ability to do some stuff. You have the ability to set up your serial connection, do a simple print line, and also use this delay. And you use these things like crazy. So at this point, what I'd like you to do, let's do one more thing. What happens if you have a syntax error? Let me just show you that. So I'm going to go ahead and put an error in there. Just put some random characters. What happens is that down here in your transcript window, it'll turn red, and if you scroll up, it'll say line 16 error. If you want to see your lines, you can go and do let's see, it's preferences, so file preferences, and turn on your line numbers. There's a bunch of settings in there, but that's how you find your errors if you do it. So there you go. Okay, so now why don't you go ahead and do your second activity, which is going to be writing your first Hello World program. And what I want you to do in your program is use not only the serial.begin, but I want you to use the print, and I want you to use both with and without the carriage return, and then also use print line, and of course use the delay when you start doing it. So at the end of this, you should play with it and start getting something that only prints once, and then only prints, a whole bunch of different times. And that's it. So after these first 2 activities, you have everything set up. Download the software. You've got it installed. You've got the Arduino connected. You've written an example program, you've used a couple of these really common functions, and you're ready to start doing more advanced tasks.